This is section 6.3, solving linear systems using inverses and Cramer's rule. Your I can statements for this section: I can solve systems of equations using inverse matrices, and I can solve systems of linear equations using Cramer's rule. If a system of linear equations has the same number of equations as variables, then its coefficient matrix is square, and the system is said to be a square system. So if your matrix A is a 2 by 2 or a 3 by 3, if it's in the shape of a square, then you have a square system that you're trying to solve. If the square coefficient matrix is invertible, then the system will have one unique solution. If we let A be our coefficient matrix of a system of n linear equations and n variables, so it does need to be a square, and we have the equation ax is equal to b, where x is the matrix of variables and b is the matrix of constants, then the inverse of a times b will give you the values of our variables. So the first thing we need to do is decide if we can find the inverse. Our equation is going to be matrix A times matrix X is equal to matrix B. But we want to get the matrix X by itself, so to take matrix A to the other side, we do use the inverse, and so we'll do the inverse of A times matrix B. Now first, our matrix A is our coefficient matrix, so it'll be 2, -3, -3, and 5. Matrix B is your constants, which is -1 and 3. So we need to make sure we can find the inverse of A, just like we did in section 2. Remember, that's 1 over A times D minus C times B. And then it's going to be matrix D, -B, -C, and A. So if we do A times D, this is going to give us 2 times 5 minus -3 times -3. And we're going to multiply it by 5, 3, 3, and 2. Because remember, you switch the A and D, make the C and B positive. Now over here we have 2 times 5, which gives us 10. 3 times 3 gives us 9. So this is going to give us 10 minus 9 is 1. So we are multiplying this matrix by 1 over 1. So our inverse matrix is just going to be 5, 3, 3, and 2. Because 1 times any quantity will just be the value itself. Now we're going to take matrix A and multiply it by matrix B. So if we have the inverse matrix A times matrix B, remember when you multiply, you go across and down. So we're going to do 5 times -1 plus 3 times 3. And if we go across and down this way, we're going to have 3 times -1 and 2 times 3. 5 times -1 gives us 5. 3 plus 3 is 9. -5 plus 9 is going to give us 4. Then we have -3 and 4, which is going to give us 1. So that means our x value is 4 and our y value is 1. Or our solution is 4, 1. If we take a look at this word problem, Belinda is investing $20,000 by purchasing 3 bonds with expected annual returns of 10%, 8%, and 6%. Investments with higher expected returns often are riskier than other investments. She wants an average annual return of $1,340. If she wants to invest 3 times as much money in bonds with a 6% return as the other 2 combined, how much money should she invest in each bond? So let's write our systems of equations. We have 3 different types. We have X, we have Y, and we have Z. And all together, she's going to invest $20,000. Now let's make the first one, your X value, your 10%. Your Y value, your 8% bond, and the Z value, your 6% bond, and together she wants to get a return of $1,340. Now to figure out our third equation, we're going to need to write this out. We know that our 6% bond needs to be 3 times more than the other two bonds combined. So X plus Y, or 10% or 8%, added together. We need our Z bond to be 3 times as many as those combined. So if we rewrite this, we need to bring the Z to the other side. So we have 3X plus 3Y minus Z is equal to 0. So that'll be our third equation. So we have 3 equations and 3 variables. So we are able to solve this. So if we find our matrix A and our matrix B, our matrix A is going to be 1, 1, 1, 0.10, 0.08, 0.06, 3, 3, and negative 1. Our matrix B is going to be 20,000, 1,340, and 0. To be able to solve this, we're going to do the matrix A, the inverse of that matrix, times matrix B. So if we do the inverse of A times B, we're going to end up with our answer as 2,000, 3,000, and 15,000. So that means Belinda's going to invest $2,000 in the bond that's going to have a 10% return, $3,000 in the bond that has an 8% return, and $15,000 in the bond that has a 6% return. Now instead of using inverses, we can use Cramer's rule. This is just another method to solve. To do Cramer's rule, we are going to first check to make sure our determinant does not equal 0. And then for each variable, we're going to do x sub 1 is equal to the determinant of a sub 1 over the determinant of a. X sub 2 is the determinant of a sub 2 over the determinant of a for as many variables as we need. So to find our different matrices, we need to find the determinant of A, we need to find the determinant of A sub 1, and we need to find the determinant of A sub 2. Now your matrix A sub 1, this means I'm just going to replace the first column with the answers. So I'm going to replace the first column with 3, 4, and then I'm going to leave the 2 and the 3 alone. To find our A sub 2, we're going to replace the second column. So our first column is left alone. We replace the second column with matrix B. So when we find the determinant of matrix A, remember it's still just AD minus CB. So in this case, we're going to do 1 times 3 minus 2 times 2, which is going to give me 3 minus 4, which is negative 1. The determinant of A sub 1 is going to be negative 3 times 3 minus 4 times 2, or negative 9 minus 8, which is negative 17. And our A sub 2 is 1 times 4 minus 2 times negative 3, or 4 plus 6, which gives us 10. So our x sub 1 is A sub 1 over the determinant of A. Our x sub 2 is the determinant of A sub 2 over the determinant of A. So this one will be negative 17 over negative 1, which is just 17. This will be 10 over negative 1, which is negative 10. So our solutions are 17 and negative 10. If we look at another one, our matrix A is 3, 2, negative 4, and negative 1. Matrix B is 6 and negative 13. Remember, matrix A sub 1 just means you replace the first column of A with matrix B. So this will be 6, negative 13, and this will be 2, negative 1. For your A sub 2, you just replace your second column. So we have 3, 4. If we replace that second column, it will be 6 and negative 13. Now we need to find the determinant of A. We need to find the determinant of A sub 1, and we need to find the determinant of A sub 2. Remember, we're still doing for determinant a times d minus c times b. So we have 3 times negative 1 minus negative 4 times 2, or 3 plus 8, which gives us negative 3 plus 8, which is going to give us 5. On a sub 1, we're going to have 6 times negative 1 minus negative 13 times 2, or negative 6 plus 26, which gives us 20. On a sub 2, we're going to have 3 times negative 13 minus negative 4 times 6. This gives us negative 39 plus 24, which is a negative 15. To find our x sub 1 is the determinant of a sub 1 over the determinant of a, which is going to be 20 over 5, which is 4. Our x sub 2 is the determinant of a sub 2 over the determinant of a, which is negative 15 over 5, which is negative 3. So our solution is 4 and negative 3.